Hey YouTube, it's JP Dillon. Welcome to part 2 of the Fisher 450T amplifier repair. In our last video, what we did was we got a little daring, bypassed all of our fuses. We jumped the dead resistor here, which once I got the schematic from the owner, turned out to be a 33 ohm half watt. So that's what we'll be replacing it with. I used 100 ohm, which got us so that we were able to verify that this channel was okay. This channel was offsetting to the rail, and for the troubleshooting pointed to the Class A device, which we were able to cross-reference and find the closest thing I have on hand, which would be a 2SA1220 or KSA1220. The KSA1220 I believe is obtainable. They're both the same device. So what we're going to do in this video is we're going to replace the Class A driver, which is this guy down here, the dead 33 ohm resistor, our pico fuses, the electrolytic capacitors, which are almost certainly bad, and then we're going to fire it up, and we're going to see if the machine then works properly, and if so, move on to the next thing, because what we did notice during previous testing was that there was a DC offset here. Now, that tells you that capacitors in the preamp have failed, but it also could tell you that if any one of these were leaky, it could have excessively biased the front end of the amplifier, which may have caused the transistor to fail, may not, very unlikely, could happen, don't know, don't really have proof. But it's just a theory. So anyways, I'm going to get the board out, we're going to remove the Class A driver, and we're going to go from there. Now, once you unwire everything, it's actually quite easy to remove the driver board. Everything just unplugs, just make a map as to where all your wires went. And then there are 4 plastic nubs that secure it. Once you release them, we get the board out nice and easy. I wish all amplifiers were this serviceable, because just to make extension cables would be a matter of a bunch of alligator clips. So you could run it outside the board if you had to, which in my opinion is quite wonderful. So let me get the machine put aside so we have a working space, and then we'll take a look at this board in greater depth. So again, this was the guy in question who was pretty much shorted collector emitter, and it's probably leaky to the base, which is why that 33 ohm resistor got torched. Doesn't like that. Also, the loss of supply here was causing an offset here, but if you watched the last video, you'd know all that. Anyways, let's see. Those are, looks like 47 at 1600 at 35, and then 1 microfarad. Those are probably your input buffer caps, but those are always bad. These things are always bad. I haven't seen a Fisher yet that didn't have leaky capacitors, at least not from this era. Anyways, let's get to it. So basically what I'm going to do is we're going to yank this, and thankfully they do mark the board, and of course it's not going to behave. There we go. They mark the board. It's hard to read there, but you know, you've got emitter base collector as far as markings on the board. This board is in fair shape. I wouldn't say it's in great shape, but it's got its use out of it. So the transistor in question is right here. Let's go ahead and desolder this and get them out, and then we'll replace it with the 2SA, KSA, however you want to look at it, same device, 1220A, which was the closest value I had on hand, which I thought would be appropriate for this Class A driver. While we're at it, we'll desolder the very charred 33 ohm resistor. And let me trim off the excess wick here. And then, let's see, those capacitors up top got to go for sure. We're just going to do the whole board while we're here. Check for any out of tolerance resistors, and put it back together and see if it runs. I'm not going to bother to make a whole bunch of extensions for it, because quite frankly it takes very little time to put this board in and out. Oh, and we still have to replace the pico fuses too, which I do have. Which, if you're curious, the service manual lists those as 4 amp pico fuses. And those go in series with the emitters, I believe. Oh, yeah. There we go. So we got those guys. There's these two here that I missed. You know, I get a lot of questions repeatedly about what solder wick I use. So take a good look at that. This is some of the best solder wick you can buy. It ain't cheap, but it just works. You don't have to prep it with flux. It's quick, it's clean, it doesn't leave a mess. I like it. Okay, so back to this. Let's go ahead and take this transistor out. That was easy. Now on these Fisher boards, be careful like what's happened here. Can't almost really see it on camera. The little eyelet that goes through the board here. These eyelets come out. It's not necessary that they be there because it still attaches from the bottom side. But yeah, I don't want it to go away anyways. Don't mind me here. I'm just looking. Clean that section of the board off. Yeah, so it's Motorola basing, collector base emitter. Let me get my device here and we'll go from there. Does this look washed out to you? Yeah, it's a little better. Trying to get some more, see if we can get some more ambient lighting. Nah, that just makes it more shadowy. All right, let me go get the transistor I need. And with the KSA, 2SA, whatever you want to look at it, 1220, the basing is Japanese. So it's base, collector, emitter. Whereas this one's emitter, base, collector. So you have to rotate the transistor to the appropriate pinout, lest you make a mistake and end up blowing the machine up. So we're going to go emitter, base, collector like this. Make sure it's down in there and nice and secure. Elevate it from the board a little bit so it can breathe. And we'll solder this guy in. All right, trim that away. So that's in. Let's take out our 33 ohm resistor. This is where the little eyelet things get annoying, because they can grab onto things where they shouldn't. Yeah, that's pretty charred, isn't it? Nice and burnt. So let me get a 33 ohm. Alright, so I've removed the old capacitors, put our 33 ohm resistor in. Here's our handful of garbage, our dead transistor. So let me go get the new parts. And the best part about all this is seeing the size difference. Here's 100 microfarad at 35 volts. And here's 100 microfarad at 35 volts. 1968-ish versus 2022. So definitely a difference. Now if you happen to screw up, the boards are correctly marked on this. The curved area, the curved side of the capacitor is the negative side. But the positives were all facing towards the front of the board, so it's pretty easy just to put the new ones in here. He says almost inserting one in a reverse biased manner that would probably kill it. Of course. Alright. And then once we get these in, we'll solder all these up. Let's see. I didn't take my 1 microfarads out of the bag yet. Flip this over. Grab them. And these are all Nishikans. I forget what series these are. Yeah. I always try to pick the 5,000 hour, 105 degree. That usually will mean I never have to see it for that problem again. There they are, all nice and happy in there. Along with a new transistor, feed resistor, all that. Let's solder them in. Then we can install this board and see if the machine tries to kill itself or not. Because either one of two things are going to happen. Either it's going to work, or there's going to be some underlying problem I have yet to see, which is going to rear its ugly head. Now, the drivers that came after the Class A device did not check out as shorted, so it doesn't mean they weren't injured, but it just means that they weren't totally shorted. So we'll have to shake the camera a bit, make everybody nauseous, and then we'll have to check the bias and make sure there's no bias creep, because that definitely becomes a problem. Let's trim all this stuff off. We still have to replace our pico fuses, so we'll do that next, and then we'll reinstall the board. And hopefully, that'll make everything happy. I'm going to reset this back down to midpoint. Both of these bias potentiometers to midpoint. Now, I know what you're saying. I should probably replace them, but they ohmed out okay, so no dead spots. I'm not worried about it. And basically, all these guys, all these ICs are a closely matched pair of PNP transistors. So in theory, you could use a match set of KSA 992s and it would work fine. It's not one of those scary, weird things like some of the phase linears used. I forget what those were. UPC something or other. I just used one the other day. Not easy to get. Anyways, let's get the machine up here and change the pico fuses. Okay, so here we are. And again, these are 4 amp pico fuses, which just about any parts distributor will have. And mine more or less look like the new ones, just a different color. So what I'm going to do is unsolder one side of them. And this is what I hate about wrapping the terminal with the wire. Because now I put the poor terminal at risk trying to get it out, which I'm not thrilled about. But it'll eventually come loose like that. That's just one. And after I do that, I'm going to cut the sides off so I can get their old insulative sleeves off. I'm going to reuse those. I'm also going to cut the crimp off, reuse that, just solder to it. Bear with me a second. So there's our old dead pico fuse there. And now we can replace it with a new one. And the old insulative sleeves will help me determine where to cut the new lead length off. And so we can see now that there's our new pico fuse right there. I'm going to trim the tiniest little bit off, and then we'll insert it into the socket. Bend it the littlest bit there, not completely wrapping the terminal. Solder this guy up. And then what I'm going to do is scrape the back side of the crimp here. And we're going to tin it and tin the lead of the pico fuse here after trimming off the excessive amount. And to tin it, I'm just setting up my roll of solder, and I'm just going to touch the iron to the crimp and the solder, apply solder to the area. I don't know if you can see that there, little glob there. And then we'll also apply some solder to the lead it's going to go onto. I'm like extra shaky today. There we go. Give it a good tug. And that's 1 of 4. So we're just going to repeat that process. Very exciting, right? Let's go to the next one. I'm going to get a solder bulb here and suck this up. Might help me a little bit, might not. Take the rest of the solder off. Everyone's going to have to look at my hand for a little bit. I think what would help with this a little bit better would be a sharp knife. Yeah, much better. Okay, that loosens it up real good. Now I can just grab a hold of this. Bend it around. And pull this one out. And then we're just going to do the same thing as we did the last one. Reuse the sleeves and reuse the crimp. Bear with me a second. All right. Go ahead and solder this guy on. Trim this off. tin the wire. And then we'll scrape and tin the connector. And we'll attach this. See if we can do it without shaking so much this time. Alright, good tug, doesn't want to come loose. That's number 2. Move these out of the way. Let's move on to number 3. Try not to get in the way of the camera here so that you guys can see what's actually happening. Since people don't seem to have a problem with the boring part of this, I'm just going to do more of the boring part. Let's get our fancy sharp knife. X-Acto. Trying to see where the bottom side of the curl is. There we go. And cut off the sleeves. Cut off the crimp. We're getting there. After this one, we'll just have one more and then we'll be able to try it out. Cut off a little bit of the excess here on the Pico fuse. All right. Turn this off. And then we'll tin it. And then we'll tin the clean and tin the crimp. Stick that on there. Come on. There we go. Give it a good tug. All right. And then lastly, we have this one over here to the very right. Hope everyone can see that okay. It's just about out of frame. Let's shake it up a little bit. I forget which Cars album that was on. Very, Good album. The debut album was good. Heartbeat City was good. It's one of those underrated bands of the 80s. Okay. We're using the sleeves. Got the crimp cut off. And let's get our last new pico fuse here. I kind of like the idea of the pico fuses because they're very quick acting and it's not exactly feasible for the owner to change them. So you probably won't see too many of these monkeyed with giant oversized fuses installed. All right. Let's tin that. Then we'll clean and tin our crimp and attach that. And then we can put the board in and test it. Won't that be exciting? And we'll get to see if I've correctly assessed the failures or if there's still more work to do. Alright, good tug on that. That's happy. Good. So our fuses are in. Let's reinstall our board. I'm going to back the camera up just a smidge here. You can see it a little better. And so now I got to snake this board in here and reattach everything. I could have unsoldered the thermal sensor too, but didn't really need to. As you can see, it's going in there nice and easy. Line it up. Let's see. What am I missing here? Oh, this terminal is getting in my way. And just push down. If you want to avoid breaking these little tabs if they're stiff and brittle, you can actually use like a 1/4-inch nut driver and just, press right down over the retainers there. Prevents you from putting too much stress on the board or anything else. All right. So let's go ahead and plug in our emitter, collector, and base. I'm guessing they left slack on these so that people could run the board. Let's see if this works better with hemostats. Yeah, it does a little. Board's going to fight me. Okay. There's our right channel output transistors. Just checking to make sure everything's tight. I'm not going to have any surprises. Come on. This one don't want to cooperate. There we go. Alright. I'm sure that's really screwing with the anti-jitter. See if I can turn that off. This camera never wants to have it off by default. No, it looks like it's not going to let me turn it off mid-shot. Alright. Okay, green one from the power supply comes back here. Getting these off was easy. Getting them on is the hard part. Especially when the terminal wants to bend out of the way for you. Alright. Sorry y'all have to look at my big hairy hands for a little bit, but just until I get these terminals on back here. This one's the ground. This one comes back here. Needless to say, these are not my favorite style of terminations. We're getting there though. You also have to be careful how you put these on, because you could stab yourself if you are not paying attention, which is fun. Come on. And last one. Another chassis ground. All right. So the board's in there. Let's go get the dim bulb tester and find out if it's going to work or not. Okay, here's the operative question of today. Will it fly or will it fry? Oh, we got a little tiny bit of current draw there. It is lit up, the lights are on. Let's see if I have voltage. Let's see, we got 32 on that side, 31.5 on that side. We still have 14 volts offset though. All right. So the right channel still is not happy. But it's not trying to blow up. It's not trying to kill this. Let's see, maybe I did something stupid, like insert the transistor wrong. Don't think I did. Nope, I did. I think I got the basing wrong. That says emitter there. Base. I have the collector and the emitter reversed. Okay, well that's not a big deal. I'm just going to yank the board out real quick and make the lead connection correction. Okay, let's see what happens now with the corrections made. There we go, 34 millivolts. Let's see, 26 millivolts. Actually, that's 4.6 millivolts, so that's even lower. Cool. That makes me like super happy. We got our plus and minus 40. Yep. All right. So the very last question is, does it pass signal? And to answer that question, there we go. It looks like it puts out full power too. Let's open it wide up. Make sure we got this all centered out. Oh yeah, man, look at that. Cool. That amp is happy. So good. We got the amp portion fixed. Bias is nominally about 16 millivolts across the emitter pair, so that's his service manual calls for 18. I might tweak it a little when we get all said and done and get ready to button it back up, but for now it's fine. It's got a healthy looking output there, no notch distortion, no nothing. So this thing's in good shape. We got the amp fixed. That's very good. New caps in there. And so I think next we'll move on to the preamp and the phono stage and make sure that's all happy. And then at the very last, we'll get to the tuner part, because the tuner wasn't working at all, I don't think. Not even static. So anyways, hope you guys enjoyed this segment. Stay tuned for part 3, where we address the preamp and the phono stage.